Before we start, I'd like to give you some general instructions for using a podcast. While you're taking the podcast, if there's something you don't understand or you need to write something down, pause the recording and write it down. If I'm working through a proof or some other problem and you think you know how to go next, pause the recording, try the problem on your own, and then restart the recording so that you can check and see how you did. Today's lesson is going to be on right triangle congruence patterns and lots of proof. Our goal is to recognize 4 right triangle congruence patterns. They are HL, which stands for hypotenuse leg, HA, which stands for hypotenuse angle, LL, which stands for leg, and LA, which stands for leg angle. In addition to that, we're going to be using CPC to prove segments and angles congruent that we don't already know from previous information. Our first congruence pattern is HL. This one's hypotenuse leg, and it's a postulate, which means we don't need to prove it, we just need to be able to recognize it when we see it. It states that if the hypotenuse and leg of a right triangle are congruent to the corresponding parts of another right triangle, then the triangles are congruent. The key parts here are that you have to have a hypotenuse, which is the longest side of a triangle. You have to have a leg, which is one of the other 2 sides, and it must be a right triangle. You have to know that before anything else happens. So, this is what it's going to look like. You have to know you have a right triangle, and you have a diagram that's going to be marked. Now, in this particular diagram, my right angles are at C and D. And I say triangle C to A to T is congruent to triangle D to O to G by reason of hypotenuse leg. This side is the hypotenuse. The longest side always opposite the right angle. So you can see our hypotenuses match. They have the same little tick marks on them showing they're congruent. And AC is a leg, and notice it matches with the corresponding leg of DO. If it had said AC congruent to DG, we could not use HL as a proof. Our next theorem is the HA theorem. Now, for HA, it is a theorem, so we have to prove it first. We can't just use it. But notice what it says. It says the hypotenuse and an acute angle of a right triangle are congruent to the corresponding parts of another right triangle, then the triangles are congruent. Again, we have to start with right triangles. You have to have the hypotenuse, and this time you have to have 2 matching acute angles. So, again, right triangle is important. On our right triangle, we have our right angles at C and at D. We have a hypotenuse marked the same way, and we have congruent angles at A and O. Therefore, we can say triangle CAT will be congruent to triangle DOG by HA. This is after we prove the theorem. We haven't proved it yet. I chose the flow proof format because I like the way you can see where everything comes from. I started with my given information. I knew that angle A was congruent to angle O, and that was given. I knew that segment AT was congruent to segment OG, and that was given. That was my angle and my hypotenuse. And now I'm trying to prove that the 2 triangles are congruent. I do know they're right triangles. I know the right angle is at C, and I know the right angle is at D. So both of these 2 pieces are given. Now, the first piece tells me nothing. A congruent to O is not going to give me, it doesn't lead to anything. Let's put it that way. AT congruent to segment OG does not lead to anything. However, the fact that I have right angle C and right angle D does. We should know something about right angles, and hopefully we know the theorem. Take a minute, think about it, write down what you think should be the reason, and then check your answer. The correct answer should be that angle C is congruent to angle D, and the reason is all right angles are congruent. Now I'm ready to say that the two triangles are congruent, and all I can use to prove the two triangles congruent are the previous congruence patterns that we already have, which means our options are SSS, SAS, ASA, AAS, or HL. So now that I know which angles are congruent, which parts are congruent, I go back and I look at my diagram. We just stated, because of the right angles, that angle C was congruent to angle D. Now looking at this, what I see are two angles and a side, but the question is the side between the angles or not? So remember the fingertip test. Put your fingertip on C, put your fingertip on A, and then look at the side. Is it between your two fingers? Since this is not between your two fingers, we're not going to use ASA because the side is not between. We did not have two sides or three sides on either triangle. And HL, we don't have hypotenuse and a leg. So our only reason can be angle, angle, side. And our statement is triangle CAT is congruent to triangle DOG. Our next theorem is the leg-leg theorem. And again, it's a theorem. We have to prove it before we can use it. It says if the legs, notice that's plural, that's both legs of one right triangle are congruent to the corresponding parts of another right triangle, then the triangles are congruent. Again, have to have a right triangle. In this case, our right angle is at C and D. Our legs that are marked are AC and OD. Those are our corresponding legs. And our other leg that's corresponding are CT and DG. Of course, we're going to prove it, but I've given you a little bit more leeway with this one. I've given you the information. CA is congruent to DO. Segment CT is congruent to segment DG. And right triangle CAT has right angle C. Right triangle DOG has right angle D. And we're trying to prove triangle cat is congruent to triangle dog. So go ahead and mark your figure with the information from the given. We already have the sides marked congruent. Now we're just adding on the fact that we have the right angle. At this time, pause your recording, attempt to do the proof, and then restart the recording and check your answer. Check it out and see how you did. I hope you did great. All right, let's move on to the next theorem. It's called LA theorem, and again, a theorem, we have to prove it before we can use it. Notice the parts on this one are a leg and an acute angle. It cannot be the right angle. It has to be an acute angle of one right triangle are congruent to the corresponding parts of another right triangle. Then the triangles are congruent. Again, we have to know we have a right triangle to start with, and here's what it's going to look like. It looks like triangle cat with our right angle, triangle dog with our right angle. Notice I marked angle T and angle G congruent. I also could have chosen angle A congruent to angle O. The difference is when we do the proof at the end, it would change the final statement or the final reason for triangle cat being congruent to triangle dog. So let's go ahead and jump ahead to the proof. Everything's set up for you. Go ahead and give it a shot and see how you do. Check your proof against the one that's on the board, on the video. See how you did. Again, I hope you did great. The only other thing we're going to be working on today are how you can use congruent triangles to prove other things congruent. Typically, it's going to be other segments and other angles, has to be, and the reason we're going to use at the end is going to be our friend CPC